What's the conversion between degrees and radians? You give me a similar statement. Pi radians is equal to 180 degrees. Cool. We want to state the units when we say, just to really make sure, verbally, everybody understands. So real quick, is everybody cool with 2b? How would you set up 2b? How would you set up 2b? What are you going to put on the bottom? 180. You can use 360. Yeah, why are you going to put 180 on the bottom? Because it's already degrees and I want them to die. I don't want it to be degrees anymore, right? I can almost get the areas. And on top I'm going to put pi as rads because that's where I want to end up. If you don't write rads, you're fine. Because I didn't write rads, did I? So then blah, 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 blah. So how do I do this problem? It's currently, you told me it's currently radians, yes? You put that down here. So where should I put, when I want to convert it, where should radians go? On the bottom. And what goes on the top? Degrees, because that's the conversion between radians and degrees, and I want the answer to end up in degrees. So where do I put what here? 180 degrees for pi radians. Yeah, and then you just throw 60 times 180 divided by pi. Just throw that in your old calculator. Is that cool? Whatever it currently is, I have to put that on the bottom so that unit dies. Right? If I want to convert 24 inches to feet, do I multiply by 12 or divide by 12? 24 inches to feet. Divide by 12. Why? Because it's inches, and so I got to put inches on the bottom so the inches cancel. So it's kind of cool. It's called unit analysis. If you just look at the units, it kind of tells you what the shit to do. Is that all right? So there's something a little evil about part A, but if I don't put a degree symbol, you know it's radians. It's the only two possibilities. So if it isn't degrees, it must be radians. What's the shortcut for part C? There's a bit of a shortcut. This looks like one that was on the... Sure, no. You don't want to find a reference angle because I want this angle to be converted to degrees.
Multiply by 180, 7 times...
Oh, okay.
Yeah.
So be more specific. What are you replacing?
The pi with 1.
Yes. Because I know pi radians is 180 degrees. I can just replace the damn thing. Now, real quick, just to show you. That's radians. I'm going to put radians on the bottom, degrees on the top. Do you see how pi cancels? So it kind of effectively gets replaced with 180. It's the same thing if I said, what's 3 feet in inches? Wouldn't you just replace feet with 12 inches? So 3 times 12, 36. Same idea. So it's a bit of a shortcut when it's radians and it has a pi present, because then you know pi radians is 180. You just replace it. You guys see that? You just replace it. Same when we do any conversion. Yes?
So in maximum 2a, do you divide 60 by 180?
No. It's on the top, isn't it? 60 times 180, what am I dividing by? What's on the bottom? What's on the bottom? Pi. So I'm going to do 60 times 180 divided by pi. If it's on the top, I multiply. If it's on the bottom, I divide. Because that's what those mean, right? So part of me always is like, I need you to see that we don't work with radians all the time, but just this problem, the way it is, it's nothing more than, if it's on top, I'm going to multiply. That's how fractions work. On the top, I multiply them. On the bottom, I divide by them. Right? That's exactly what I do here. Okay, maybe. Yes? 4? Oh, yeah. Yeah. What quadrant are we in? And how do you know? How do you know we're in the fourth one? I love it. You should just say, because it's just, you told me, man. Because it tells you right here, in the quadrant 4, yes? Does it make sense that secant theta is positive? What is secant related to? Cosine. Quadrant 4, what's true about cosine? Positive. It's on the positive x-axis, right? So everything so far makes sense. Jeff didn't go insane. I could go insane in a second. Something else that makes sense. What's the biggest that cosine can be? What's the biggest output that cosine can have? 1. So what's the smallest outputs that secant can have? 1. Because doesn't secant go up from there? So secant will always be greater than or equal to 1 or negative 1, right? It's got to be out. That's why secant visually looks like this, because it can't be in here. I need this to make sense, because what's on the top of secant? What's on the bottom of cosine? Definitionally. Cosine is what over what? Basic definition of cosine. X over R. So secant, R over X, correct? R is the hypotenuse. What's the longest side in the right triangle always? Hypotenuse. So if you just look at it that way, secant has got to be greater than 1 or equal to. Right? Okay, I'm sorry. Did anything I just say, was it involved in any question I asked? No. But I just want you to see, this makes sense. Secant, 25 over 24, that makes sense. It's positive because I'm in quadrant 4, that makes sense. Okay. Did you have to do what I just did? No. But you know, I just talk about shit. What trig function can you get without doing barely any work? We just basically said it. Cosine, what's cosine? 24 over 25. That kicks so much ass. So you have 2 ways you can go with this. One way is draw a triangle, where secant theta is 25 over 24, right? Can you guys do that? Draw a triangle where the secant would be 25 over 24. Put theta there in the base, because I'm not some weird Secretella head here. Where should 25 go? Hypotenuse. And where should 24 go? Yes, because it's cosine, right? So we know cosine is 24/25. Now what I normally do is I don't worry about, do you all agree with me that some trig function values will be negative? Couldn't you find that out kind of separate? Can anyone tell me one trig function value that's going to be negative for number 4? Sine. Why will sine be negative? Because the y is negative in the quadrant 4. You guys with me? So what I normally do is I just draw a physical triangle, get all the values, and then just put negatives on the 1. So the last thing I do is, what quadrant am I in? Let me put a negative there. What you could do instead, if you wanted to, is you could draw your triangle a little bit differently. I'm in quadrant 4, correct? So let me just draw my triangle there. So this will be 25, this will be 24, and this will be negative something. That's up to you. I don't like doing it this way because it's easier to forget the negative. I'd rather reinforce myself, where is these things negative, where are these things positive. To me, it makes it easier, but if you like this way, it's completely valid. Because now this isn't a physical triangle necessarily. This is just, it's a negative, it's down. So it's negative, of course it is. This is just an XY plane thing. You guys see that? This is a physical triangle. This is XY plane thing. Does anyone know what that would be? This is a weird 7, yeah. I'm pretty sure, I was trying to remember, yeah, 7. Remember like 3, 4, 5 triangle? There's a 5, 12, 13 triangle. This is 7, 24, 25 triangle. There's all these weird triangles. Why is that kind of weird? If I just make up a right triangle out of nowhere like I did on the quiz, almost definitely one side at least is going to be a square root, correct? Because there's a bunch of squares the old Greek dude used, right? Not because he decided to, because it's the way it is. I guess that all with, I'm sorry. So there are a few, not a few, there's an infinite number, but there are, how do I even say it? Less right triangles where all the sides are whole numbers. That's weird when we hit one. We go, whoa, shit. So can you guys, how would I figure out the other triangle? Can I just figure them all out now? Once I got all four, that's awesome, Jeff. Once you got all four sides, once you got all three sides, I can just make all the ratios and I'm basically done, yeah? Now, a whole other way to do this. This is cool, this is the way I would do it. I would do it this way. This is basically the same, but you put the negative right in your face. You with me? Here's a whole other way, a third way to do it, is to not even draw shit. Can anyone tell me how are sine and cosine related directly? Is there a relationship between the two, direct? No. Tangent is related to sine and cosine. I want a direct relationship between sine and cosine. Is there an identity? Is there an old Greek dude identity? Is there squares maybe? Sine squared theta plus. Sine squared theta plus cosine squared theta is 1 because they have to live in the unit circle. So I feel like this would be an option very few of us would pick, but if you wanted to, real quick, what is sine theta from the triangle? Negative 7 over 20. Watch this. Isn't cosine squared theta plus sine squared theta equal to 1? That is something you have to memorize. Didn't I tell you that cosine theta is 24 over 25? So you could solve that to get sine. This would be sine squared theta equals 1 minus 24 squared over 25 squared. That looks exciting, doesn't it? You could do it this way. 25 squared minus 24 squared is 7 squared, blah, blah. You eventually get here. You eventually get, let me see if I can make this. Has somebody got to take a square root? Yes? Normally when I take a square root, what do I put in front of it? Plus or minus. In this case, the plus or minus is a choice I have to make as a human, because I know I'm in quadrant 4, I would pick negative for sine. You guys with me? All of the sine and cosine shit and all the identities have squares on them, because when I get to a point where I take a square root, the plus or minus depends on which quadrant we're in. That's how I choose which one. You don't have to do it that way unless I make you. Okay. And there's a chance I will make you.
What is that called? Like, what are the three?
This is the Pythagorean identity for trig. Yeah, the trigonometric Pythagorean identity. And there's 2 other ones that we built, right? And at this point, you're supposed to memorize those. You should have to have those memories. Do we have more identities to memorize, Jeff? Yes, we have lots more. Can we do them right now, Jeff? No, I'm sorry. We'll do them after this test. Yes. Oh, I'll let you guys add after this question. 9. Oh, okay. Well, that's the one I thought we'd start with. So, all right. Well, let me give you a little bit of help. I gave you a lot of help already, because the hardest part about this kind of problem is drawing the damn thing. So let's see how I drew this as I lag in real life. That's weird. So we're walking towards Mount Doom. So here's Mount Doom, right? Okay. So we're walking towards it. At one point, we measured the angle of elevation to be 32 degrees. Yes? There's Mount Doom right there. That wall is Mount Doom. How do I know that? Because I can hear an evil sound every now and again from up there, right? If I walk closer to it, don't I have to look at farther angle up to see the top? That's exactly what the shit's going on here. So we're here, and we have to look 32 degrees up to see the top. We walk 1,000 more feet, and now it takes 35 degrees to look at the top. If I was right at the damn base, I'd have to look straight up 90 degrees to see it, yes? Like the seat you sit in at the movie theater if you're really late. Oh, shit. Okay. So everybody with me? So on the test, I ain't giving you the damn picture. Oh, shit. So what is it they really want? They want to know the height. That's what they want to know. Why did I put this here? Because I have, where are my right triangles at? There's one big one, and one that's a little smaller, yes? So I need that. I don't know why I put x2. I think I know why, because I used to have a different problem here. I used to not know this one. So can't I set up, for each right triangle, I could set up a trig statement? Which variable do you not care about? Careful, they want me to estimate the height. So which variable do we care a lot about? H. Which variable do they not tell me or ask me about?
X.
X2, yeah. X1 unite. Okay. So what you want to do, look at the big ass triangle. How long is this side of the big ass triangle? Be careful, because does 1,000 feet show up in any right triangle by itself? No. That's in this weird ass scalene triangle, yes? That is a weird triangle. We're not ready for that yet. So what trig function relates this angle with what I want to know and what I know something about? Huh? Ah.
Oh, no.
Every triangle, do I care about its hypotenuse in this triangle? Nope. I don't give a shit about that hypotenuse. So I'm going to use tangent. So you can set up a tangent equation for the big ass triangle and a tangent equation for the slightly smaller triangle. And somehow between the two of them, you want to get rid of x because you don't care about it. And we're going to talk more about that tomorrow because I'm going to let you guys go. I'm mostly letting myself go. Yes?
What is the height of the
What will it be?
What's the answer?
I don't know. Shit. Sorry, man. I've done this problem before, but it's been a little while, so I can't remember. I don't even want to try to come up with something on the spur of the moment. I'll have the answer for you tomorrow, though, so we'll all find out.